I guess what you'd call a direct translation problem. And we're supposed to find the value of an integer. Let's go ahead and give it a name. We'll go ahead and call that integer just x, I guess, standard math variable. Okay. Now, we actually directly translate this. It says when 20 is added to a positive integer, that's what I do, you get a perfect square. Then also when 168 is subtracted from that same integer, you also get a perfect square. So again, all of this language is directly translated by these two statements right here. Now, it's fairly convenient at this point that when you subtract the two equations from each other, that is the right-hand side from the left-hand side, the x's cancel. And notice right here, you get actually 20 minus 168 is the 188 you see right here, and then the x's, of course, go away on us. Now, this works out very nicely because we do have a difference of two squares results, and you equate the factor pairs. Now, what we have right here is actually three possibilities. 188 has three separate factorizations. You can see them there. 1 times 188, 2 times 94, and 4 times 47. So what we actually do right here is we just create systems of equations here. We actually equate m plus n with 1 and m minus n with 188. Now notice when we do that and we add the two equations, if we add this equation to this equation, the n's cancel, and so we get 2m is equal to 189. 2m is equal to 189. And now right down here, when you divide by 2 right here, you get m is not, let me get a little more space here. You actually get that m is equal to 189 over 2, and that's not an integer. Remember, the number theory, we're dealing with integers here. So we have to rule out this possibility right here. Okay, that is not an integer, and so we have to scratch that out. Okay, no can do. All right, now on the very next line here, we actually equate these next two factor pairs here of 2 and 94 with the factorization itself. And the very same kind of result right here. If you add these two equations together, the n's cancel, and then you get not 2 plus 94 is 96. And here we catch a break because m is equal to, let me get a little more space here, m is equal to 96 over 2. M equals to 96 over 2. But that's equal to 48, right? Now notice, so we have an integer value for our m here, which is 48. And let's back up here and notice that if we know m, we're going to know x right here. So let me we have 20 plus x from the direct translation here is equal to m squared. So let's bring that back down. So in other words, we have 20 plus x is equal to m squared. So let's recopy that. 20 plus x. And again, this is just from directly translating the problem. 20 plus x, I've already forgot what is it. 20 plus x is equal to m squared. Okay, so what that's going to tell us is that x is just equal to 48 is m, so x is going to be equal to 48 squared. (48 squared minus 20). Okay, folks, and that number ends up being 2284. $2284. Okay, y'all, and that's the final answer. Now notice you can see here on this very last case, this is the answer because on this very last case, you get the same kind of circumstance. You see, this is not going to work out, right? This case won't work out because 2m is equal to 51. And let me just scratch that case. You can see that it's the very same kind of process. This piece right here is also going to yield a non-integer value. So 2284 is the final answer. Hope you enjoyed.